this podcast, we're going to walk through both drawing haloalkanes as well as naming haloalkanes, and the problems that I've selected come from your guided practice. All right, so let's start with drawing from a name, and we're going to start in the same place that we always do. We're going to start with the parent chain, and we're going to fill in the branches second, and then we're going to fill in the hydrogens that are needed after that. And I'm going to do these in different colors so you can kind of see the different steps, but it will be one structure at the end. So let's start with heptane. Hept tells me we have 7 carbons. Ane tells me they're all single bonds. So I'm going to start by spacing out my structure. I'm not going to draw any bond lines. 1, 2, 3, 4, 5, 6, 7. The reason I'm not drawing bond lines is because you will be required to draw this in a condensed structural formula, and we only use bond lines if we have a double bond, a triple bond, or we have a group coming off of the parent chain. We wouldn't do it between carbons in the parent chain. All right, so that takes care of heptane. Now we have groups to add to this. So because I'm drawing it, I'm going to start numbering on the left, and I will erase this when I'm done. You want to make sure that you get rid of that, but this is just kind of for me to orient myself. So I am told that I have 2 chlorines in the 1 position and the 4 position. So I'm going to go to the first position. I'm going to draw my chlorine, and the 4th carbon, draw my chlorine. Okay, so those are taken care of. Now we have methyl groups to add. Our methyl group, which is a 1 carbon group, is coming off of the 2nd carbon. So on the 2nd carbon, I'm going to draw my methyl group. That takes care of that. So what I have done here is I have addressed every single group and the parent chain. The last thing that I have to do now is to go through and add hydrogens to it. So my first carbon is attached to only another carbon and a chlorine. That's 2 bonds, which means I will have to add 2 hydrogens to make a full octet. On my 2nd carbon, it's attached to the 1st carbon and the 3rd carbon, as well as the methyl group. That's 3 bonds, so I only need 1 hydrogen here. The 3rd carbon is attached to carbon 2 and carbon 4, which means it has 2 bonds, so it will need 2 hydrogens to complete the octet. Carbon 4 is bonded to carbon 3, carbon 5, and chlorine for 3 bonds, so it only needs 1 hydrogen. Carbon 5 has 2 bonds. It's bonded to carbons 4 and 6, so it needs 2 hydrogens to complete its octet. Carbon 6 is also bonded to 2 carbons already, so it needs 2 hydrogens. And finally, carbon 7 is only bonded to carbon 6. It will need 3 hydrogens to complete its octet. I would erase all of these numbers, except for they will go back and erase them from the beginning, so make sure when you're drawing yours that you erase that as well. All right, let's do another practice problem. Starting with our parent chain, we have a pentane. Pent, think about a pentagon as 5 carbons, all single bonds with the A and E. So I'm going to draw my parent chain, and I'm going to leave my carbons lots of room because I don't know how many hydrogens they're going to need or if they have bonds or what's going on. All right, parent chain taken care of. Next, we're just going to go in order. I have 2 bromines in the 1,2 position. I like to start counting from left to right because I'm drawing it, so spatially that makes the most sense to me. You're welcome to count in any direction that makes sense to you and still gets the right number of carbons and the right groups on it. All right, so we have bromine groups on the 1st carbon, and we have a bromine group on the 2nd according to this. We're done with that. Our next set of groups, we have a methyl on the 3rd carbon, and we're done with that. So now we've addressed the parent chain and all the groups that are coming off of it and the correct carbons that they're coming off of. So the last and final thing to do is to fill in hydrogens so that every carbon has 4 shared pairs of electrons or 8 total electrons. Carbon 1 is attached to carbon 2 and bromine, that's 2 bonds. It'll need 2 hydrogens. Carbon 2 is attached to carbons 1 and 3 as well as a bromine. That's 3 bonds. It only needs 1 hydrogen. The same goes for carbon 3. It only needs 1 hydrogen. Carbon 4 is attached to carbon 3 and 5. That's 2 of the 4 bonds, so it's going to need 2 hydrogens. Carbon 5 is at the end and it only has a single bond to carbon 4, so we need 3 hydrogens to complete its octet. All right, so let's take a drawing and let's work on naming it. We're going to start where we always start, and that's with the parent chain. And because we have a cyclic, we're going to count the cyclic as being our parent chain. It has 5 carbons. We're counting each of those junctures, or the points where those lines come together. So 5 carbons is pentane, all single bonds. That's why we give it the ANE, and it is cyclic. So I'm going to have to call it cyclopentane. All right, next we have 3 groups that we have to deal with, 2 chlorine groups or chloros and 1 methyl group, a single carbon branch. So I have to figure out next how I am going to number these. So I can start with the chlorine. I can start anywhere as long as I number in order. So I could count clockwise 1, 2, 3, 4, 5. Okay, and I would have, if I were using this numbering scheme, I would have branches in the 1, 2, and 3 pattern. Or I could count, starting with methyl, I could count 1, 2, 3, and if I were counting in that direction, I would have groups on 1, 2, and 3. So because these are equal, I am going to go ahead and defer to our alphabetical rule, and I'm going to go with the red option, and the reason I'm going to do that is because chlorines come first alphabetically, so I'll give priority to that because everything else is the same. So I have 2 chlorines, and chloro alphabetically, the C comes before my methyl group. So I'm going to start with chloro first in the name. I have chlorines on the 1, 2 position, and because I have 2 chloros, I don't want to say chloro-chloro, I say dichloro. I am going to use commas to separate my numbers and dashes to separate numbers from letters. Next, I have a methyl group and it is on the 3rd position. So I have to again state what carbon it's coming off of. So this would be 1, 2 dichloro, 3 methyl cyclopentane. And it's okay for this name to all run into itself. You don't have to put spaces in it. All right, this one should feel easy compared to the last one. We have a cyclic alkane that has 3 carbons in it, which is pro and prop, and they're all single bonds, so it's propane. Because it's a cyclic, I'm going to add on cyclopropane. And now I need to address these 2 groups that are coming off of it. Well, since I get to choose where we start numbering, I am going to give this carbon number 1 because that will give it the lowest number possible. There are 2 fluoros, so I would say difluoro, cyclopropane, and I have to address what carbon each of those is coming off of, which is why I have to say 1, 1 difluorocyclopropane.